Hello everybody, I am manideepapal. Here I am discuss about network theorems. So learning objective of the network theorems is to develop an understanding of the network theorem of electric circuit. So if when we use network theorem, then complicated electric circuit becomes more easier to easy and simple. So first of all, we may discuss about the superposition theorem. So it states that in any active linear resistive network containing several sources, the voltage across or the current through any resistance or sources may be calculated by adding algebraically all the individual voltages or current caused by the separate independent sources acting alone, with all other independent voltage sources replaced by short circuit and all other independent current sources replaced by the open circuit. So here here I have drawn a circuit with two independent voltage source. So independent voltage source here, then we have to calculate the current through the resistance R2. So to calculate the current through resistance R2, we have to first assume that one independent voltage source acting and other independent voltage source replaced by short circuit or by independent or by their internal resistance. Okay, so here if it is an ideal voltage source, then internal resistance will be 0, so it is replaced by a short circuit. So next figure shows like this: V1 acting on the circuit and V2 replaced by a short circuit. So now we have to calculate I1. So I1 will be calculated by a voltage dividing rule. Okay, so here we can get the current through the resistance R2. Okay, again next we have to calculate the current through the resistance R2 when V2 is acting alone, when V1 is replaced by a short circuit. Okay, then we get a current that is known as a I double dash. Okay, now superposition theorem states that we have to adding the two current source current. Okay, that is I1 I dash and I double dash. Then we get the total current through the resistance R2. So it is more easier when the complicated circuit or many sources are there, then we have to calculate, we have to consider one independent source and other sources should be short circuit or open circuit, and respectively short circuit or open circuit. Okay, so this is called the superposition theorem. Okay, in our in class activity we solve many example of superposition theorem. Okay, next we discuss about the Thevenin's theorem. It states that with respect to terminal pair AB, the network may be replaced by a voltage source VTS. That is here a network N and terminal A and B. So it states that this network is replaced by a VTH, that is called voltage, Thevenin voltage, and with a series with a ZTH, that is a Thevenin impedance. So with all the sources, so now this VT and ZTH can be calculated by ZTH is the internal impedance of the network N as seen from the terminal A and B with all the sources set to 0, that is with all the voltage sources shorted and all the current sources open circuited. leaving behind their internal impedances. Okay, so in this way we calculate the ZTH. Okay, so when we calculate the ZTH and VTH, then the VTH is series with the ZTH. Okay, so this is called the Thevenin equivalent of the network N. Okay, so it is more simple circuit. Okay, so when a complicated network N is modified by a simple circuit, so when we have to do this, then we can use the Thevenin theorem. So in our in-class activity, we can solve any problem of network Thevenin theorem. Okay, thank you.